This is Algebra 2, Unit 3, Lesson 5 on inverses of linear functions. Now, in a previous lesson, we learned about functions and their inverses. We learned that functions have inverses that are also functions if they are one-to-one. Now remember, one-to-one means for every x there is a unique y. So each x has its own y that is unique. So that means when you do the inverse of the function, it will also be a function itself if it's one-to-one. So, with the exception of horizontal lines, all linear functions are one-to-one and thus have inverses that are also functions. So if you have a line, you immediately know that its inverse will also be a function, except if it's a horizontal line. That's something different. All right, now, let's take a look at an example. On the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. How can you quickly tell that y equals 2x minus 4 is a one-to-one function? Well, we have to know if it's one-to-one by using the horizontal line test. If we draw a horizontal line and it touches the function only once, then the function is one-to-one. So therefore, its inverse will also be a function. All right, now let's graph the inverse. Remember, when you graph the inverse of a function, all you have to do is switch the x and y coordinates. So if you start with a function that's xy, its inverse will be yx. So if this is f of x, this will be f inverse of x. So it will switch the coordinates. All you have to do is switch the coordinates. So on a line, it's really easy. You just go point by point. So this first point right here is -1, -6. So its inverse will be -6, -1. 1, 2, 3, 4, 5, 6, -1. Okay? 0, -4 will be 1, 2, 3, 4, 0. This point right here is 1, -2. So this will be -2, 1. -2, 1. And then we have 2, 0 will be 0, 2. Will be there. And then 1, 2, 3, 1, 2, 3, 2 will be 2, 3. And 1, 2, 3, 4, 1, 2, 3, 4 will be 4, 4. Will stay 4, 4, which will be right there. And then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 5, 6 will become 6, 5, which would be right here. All right, let me draw my inverse in. I'll do a nice red line so you can see it. There's my inverse. And what can be said about the graphs of y equals 2x minus 4 and its inverse with respect to line y equals x? Well, look at your rule right here. xy becomes yx. Remember that an inverse is a reflection over the line y equals x. So they are symmetric with the line y equals x. So this line that we just drew, the inverse, is symmetric with y equals x. If I fold it on y equals x, it will line up perfectly with the original line y equals 2x minus 4. All right, now, what's going to be different in this lesson is we are going to figure out the equation of the inverse. So let's see if we can do it from the graph. Well, what kind of graph is this? This is a line. So how do we find the equation of a line? So the equation of a line is y equals mx plus b form. So we need to know what m is, and we need to know what b is. So if I look at my graph right here, where's my graph? Here's my graph. All right, my b is easy. My b is going to be 0, 2. It's this point right here because it's the y-intercept. So b is going to be 0, 2. And then my slope, it's going to be up 1 over 2. So it's going to be 1/2. So m is 1/2. So my equation of my inverse will be y equals 1/2 x plus 2. Okay, now, if I wanted to find the equation of the inverse in y equals x plus b over a form, I can rearrange this so that it's in a different form if I wanted to combine this into one denominator. All right, so what I'd have to do is take my equation, y equals 1/2 x plus 2, and technically this is going to be 2 over 1. If I wanted to combine these into a single denominator, I would need a common denominator, right? Well, I know this is going to be y equals 1/2 x, and what common denominator would I need would be 2. So what is 2 over 1? It's actually 4 over 2. So now I can combine my numerators together, would be x plus 4 over 2. So this is just another way that you can see it. It's the same equation. So if we just put this back together in the original one. Now, what we're going to be looking at is how do we find the equation of the inverse algebraically? Well, it has to do with looking at the rule that we have. The rule for inverses is switch the x and y variables in the original equation and solve for y. So that's what we're going to do. If we have the equation y equals 5x minus 20 and we want to find its inverse. So what I do is I switch the x and y. So y equals 5x minus 20 becomes x equals 5y minus 20, because with an inverse you switch the x and y. All right, now this doesn't look like any of these, does it? No. Let's solve it for y equals mx plus b form. So if I add my 20 here, so x plus 20 is equal to 5y, and then I divide by 5. Make sure you divide everything. And y is going to equal 1/5 x plus 4. And that is the equation of your line. That is number 4. So that would be the equation of the inverse. So your trick to doing these, when you're following the equation of any inverse, switch the x and y and solve for y. It can be work for any. It can work for a linear equation, quadratic equation, exponential, however you want to do it. Switch the x and y and solve for y. All right, let's try another example. Which of the following represents the inverse of the linear function y equals 2/3 x plus 8? Well, let's do the rule. If I want the inverse of the function, I want it to be y equals mx plus b form, the first thing I have to do is switch the x and y. So this becomes x equals 2/3 y plus 8. Okay, so let's do a little algebra here. We want to get rid of the nasty fraction. I want to get rid of the 3 in the denominator, so I'm going to multiply both sides by 3. Algebra trick. 3x. This 3 will cancel this 3, leaving 2y, plus 8 times 3 is 24. Make sure you distribute the 3 through the parentheses when you do that. Now solve for y. What do we do? Subtract the 24. So 2y is equal to 3x minus 24. And then divide by 2. Make sure you divide everything by 2. And you end up with y equals 3 over 2x minus 12. So 3 over 2x minus 12 would be number 2. Okay, so now that we have that down, see if you can do number 4 and figure out what the y-intercept of the inverse of this function is. Give you a hint. You might want to figure out what the equation of the inverse is first. Now this method works no matter what form the linear function is in. We just did slope-intercept form y equals mx plus b, but it can also be done in point-slope form. It's y minus y1 equals m times x minus x1. So the method of finding the inverse and plotting it is the same. If we have this equation and we want to find its inverse, y plus 6 equals 4 times x minus 2, the rule says switch x and y. So this y becomes x plus 6 is equal to 4 times y minus 2. Okay, now notice each of these have parentheses around the x plus 6, so I'm going to do that. Now, I'm doing that for a specific reason. Now, looking at this problem, I want to solve this for y. Now, I want to leave the parentheses as x plus 6, so I know it's either going to be 1 or 2 here, because that's going to be my answer. I want to solve this for y, so I want to get rid of this 4. Well, since this is multiply, I can divide the 4 right now. And I can divide the 4 over here, but remember, there's an imaginary 1 in front here, so this is 1/4. So this is 1/4 times x plus 6 is equal to, well, what's left over here? Y minus 2. So which one does that look like? It's number 1. So there we go. If you want to, you can also distribute the parentheses, solve for y, do it that way. But notice here, if we can get it to keep the same form, we're all set. Okay, so now that we know about inverses, see if using the point-slope form you can figure out which one of these points lies on the graph of the inverse. So we'll talk about that in class the next day. And we will also talk about which of the following linear functions would not have an inverse that is also a function, and explain how you made your choice. Okay, so we will talk about this one in class. Think about how you would know that the inverse is also a function.